Hello. Now we are going to look at spheres. So a sphere is just like a tennis ball or a football. And the formulas for spheres are on page 10 of the formula tables or log tables, so LT for log tables. Now, the formulas for a sphere, and the way I tend to draw a sphere is you draw a circle and then you draw a little indicator of like a shine that you would see on a ball when it's in the sunlight. So that's what that is, to indicate that it's a three-dimensional sphere as opposed to a two-dimensional circle or disc. The volume of our sphere, if we have our radius r, is going to be 4/3 multiplied by the number pi, our 3.14 number, multiplied by the radius cubed. And we expect it to be cubed because it's a volume. And then we have the surface area is 4 multiplied by pi multiplied by r squared. And again, pi is often made as 3.14, and it could also be the pi calculator on your, the pi button on your calculator. So we would get second function, and then it's usually down the bottom of the calculator. A hemisphere just means half a sphere. And this is a word that we're supposed to know. So hemisphere means half a sphere. And it just means that we cut a bowling ball or something like that in two. Now, often a hemisphere will be a solid hemisphere. That means that there will be a circular surface on the top. So we've sliced our sphere in two, and then we would have a circular surface on top, and then we would have half of the sphere as the body of it. So the volume is just half of the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. If we half 4, we end up with 2/3 pi r cubed. The surface area, if it's a solid hemisphere, is going to be the top is just going to be a circle of pi r squared, and then this is going to be the sides or the base of it or the bottom of it. And we need to be careful. We could be given a situation where we have something like a soup bowl, and then we would have the surface area, we would say, would just be the half of the surface area of the original sphere. But if we're told we have a solid hemisphere, we need to keep in mind that there would be a circular top to our hemisphere. Now let's put these into practice. So we have a sphere, and we can see it has a diameter of 24 meters. And I say a diameter because I'm going from the circle through the center out to the circle again, all in a straight line. So that means that this is a diameter line. It's going directly through the middle of the sphere. And I'm asked to find the volume of this sphere in terms of pi, and I'm asked to find the surface area to 2 decimal places. So if I see that I have a sphere, I'm immediately going to write down the two relevant formula that I know. I know I have 4/3 pi r cubed for the volume, and I know that the surface area is going to be 4 pi r squared. And if I forget them, or if I want to double check them, as I often should, then I would go to page 10 in my log tables. But if I see this type of shape, I'm going to write down those two formula. And it's by identifying shapes and writing down the relevant formula that we do more challenging questions, that we set ourselves up to be able to do more challenging questions like the second one we have here. Now, our first business is to get to get the volume in terms of pi. So what's the radius going to be? Well, I want to know the radius. I know the diameter, I'll call it d, is 24 meters. I know that the radius is half of that because I have a radius, and a radius makes up my diameter. So the radius is going to be 24 all over 2. It's going to be 12 meters. So the volume then of my sphere in terms of pi, so in terms of pi, we remember, means that we leave the pi alone. It's effectively like an x, like a variable that we would leave alone. It isn't, but that's effectively how we treat it. It's just left as part of the final answer, like we might end up with 7x is the final answer in some algebra problems. So we write down our information. We know the radius is 12 meters, and that's the only thing we actually need to know. So we have the volume is equal to 4 over 3. I've already written my formula here, so I'll just sub in multiplied by pi multiplied by 12 squared. Now, when I'm putting stuff into the calculator at this point, I'm going to just put in the 4 over 3 multiplied by 12 squared. I'm not going to put in the pi because I want pi in my final answer. So I don't want the calculator to tell me what this is when you put in the number pi. I want pi written next to my final answer. So I want to find out what these two numbers are multiplied together. And when I do that, I get volume is equal to 2,304 multiplied by pi. And what are my units going to be here? Well, it's a volume, and I'm dealing with meters, so that means it's going to be meters cubed. And now the surface area. And I want that to 2 decimal places, so my surface area, this is a little bit far away, so I'm going to rewrite my formula. I want it right next to me when I'm subbing in, and I know that the radius is 12 meters, and I want this to 2 decimal places. So this is just substituting into our formula. So 4 pi, 4 multiplied by pi, we can put in brackets. In this case, we're going to put the pi into our calculator. So second function and then find the pi button. Multiplied by 12 squared. And we put that into our calculator, and we are going to find that we get 1809.5574, 9. And I want to go to 2 decimal places, so I need to round this. I'm going to round to 2 decimal places, and I need to round up because there's a 7 here. So the surface area to 2 decimal places is going to be 1809.56, and that's going to be meters squared. Now, there's an error in what I wrote. This answer is perfectly correct, but there's an error in what I wrote here. And it came about because I didn't write the formula directly above where I was subbing in. So I could have very easily made a mistake. So I am going to go back and put my formula in directly above, and I'm going to change this to being cubed as opposed to squared. So this is a nice demonstration of why it is we always write the formula directly above where we substitute in. Because had I not already worked this out on paper and had the correct answer from having it written correctly the first time, I would have made a mistake. And if we were doing this in an exam, we would have lost marks for very little reason. So always write down the formula directly above where you substitute in, because when we start to get to more complicated formulas like this, it's easy to make a slip like that. Whereas when I have the r cube directly above, I can very easily check that the structure of what I've written is correct. Now, let's get into our more complex question. So imagine that we have a cup of water or a barrel of water, and we throw something like a bowling ball into it. What's going to happen to the level of the water that's in the barrel? It's going to go up because we've thrown something into the barrel, so the water is going to rise. Space is being taken up by the bowling ball, so the water must rise because there's volume being taken up by the ball. Now, what I've tried to draw in here is the old level of the water, so the lower level of the water before we put the bowling ball in, and then when we put in the bowling ball, our water rises in our barrel by 10 centimeters. And that's the new water level in our barrel. The barrel itself is a cylinder, and it's 12 centimeters. It has a radius of 12 centimeters, and we have again risen by 10 centimeters. So based on that information, can we figure out what the radius of the ball must be? So it's a spherical ball, a bowling ball. The key insight that we have to have is that, as I said, the reason why the water level has gone up is because we have the bowling ball in there. that means that the volume of the bowling ball must be the same as the volume of this dashed cylinder. So from this circle down to the blue circle, this cylinder of water, of higher water that we have now, is due to the volume of the bowling ball. So that means if we could work out the volume of our water between the old water level and the new water level, if we could work out the volume of that cylinder, we would know the volume of our sphere. But let's write down all of the stuff that we know. We know we're looking for ore. Ore is actually written for us on the diagram. So ore for our sphere. So let's put a circle for our sphere, and then over on the other side we'll do our information for our cylinder. We need to break down the information that we've been given. So for our sphere, the radius is what we're looking for. And what do we know about spheres? We know that their volume is 4/3 pi r cubed. And we know that their surface area is going to be 4 pi r squared. And for a cylinder, what do we know? Well, we know its radius is 12 centimeters. And the cylinder we're interested in is this cylinder of water from the old level to the new level. That's the volume due to the sphere through to the bowling ball. So we're interested in a height for our cylinder of 10 centimeters, because this is the cylinder we're interested in. And we know that the volume of a sphere is going to be pi r squared h, and we know that the surface area is going to be, depending on the type of, actually this would be an open one, so we wouldn't have that. Pi r squared plus 2 pi r h. So now I have all the information I'm given, and I have all of the formulas that I can use. And I know that what I can recognize logically is that this volume here, volume of this cylinder here, of the new water, must be the same as the volume of our bowling ball. So can we use that to figure out our radius that we're looking for? So we can see the importance of writing down what we have been given. So I know that this volume must be the same as this volume. The rise in the water volume must be the same as the bowling ball volume, because that's where the rise came from. So that means that 4/3, so the volume of the sphere must equal 4/3 pi r cubed, must equal, I'll put a little circle for our ore that we're looking for, must equal pi r squared for our little cylinder, h for our little cylinder. And you can mark these whatever you want. You could do the 0 and 1 for these. We know that those volumes must be the same. Oops, volume. So we can sub in and see if we can solve for our ore 0, for our ore sphere. So 4/3 pi ore 0 cubed, or ore sphere cubed, pi, and we know r squared, that's the ore of the cylinder, so that's going to be, or the barrel, that's going to be 12 squared on 10 for the height. So now we have an equation that only has one unknown in it. So we have 4/3 pi r 0 cubed is equal to pi times, let's put in the number, it's going to be 1440 pi. Now I have a common factor of pi, so I can divide both sides by pi to get rid of my awkward looking number, and then I have 4/3 cubed is equal to 1440. Multiply both sides by 3 to get rid of the 3 down here, because we have our r0 divided by 3. And then divide by 4. Pardon the jump. And then we need to take the cube root of both sides. And when we take the cube root of both sides on our calculator, we get 10.2598, and we usually round to 2 decimal places if we're not told to do otherwise. And that's what we need for now.